Okay, this is assignment 21.2b. I am recording it for the second time because I found a couple mistakes the first time, and besides, I just got a brand new stylus. My writing looks so much nicer. You'll be so proud of it. Your old lady teacher, learning new tricks. Here we go. I hope that you already watched Mrs. Franken's video on this, or that you read my typed notes on this. Anyway, we're going to do a couple problems. This says, a college entrance exam is designed so the scores are normally distributed with a mean of 500 standard deviation of 100. First thing I'm going to do, go over to the curve, let me look at page 2, and fill those in. My mean was 500. And then I have a standard deviation of 100, and plus 1 actually means 500 plus 1 standard deviation. So I get 600. Plus 100 is 700. Plus 100 is 800. Then I have to get smaller. Go to the left. Negative 1 means the mean minus 1 standard deviation. So going this way, minus 100. So I have 400, minus 100 is 300, minus 100 is 200. These are what we call our X numbers. Those are the numbers that are usually given in the problem. These right here, those are our Z's. The Z's are the numbers that we use to standardize whatever numbers we have, standardize them so that we can then use all these percents on the curve. Okay, let me look and see what they're actually asking us for this time. What percent of the exam scores are between 400 and 600? Okay, so I'm talking about X numbers between 400 and 600. Now, what I need to do is convert those into Z numbers. 400 is at negative 1, 600 is at positive 1. Negative 1 for the 400, positive 1 for the 600. I don't like that. See if I can fix that. Okay, so I go back to my curve, and I have several percents typed across the curve, but there are other percents that it's good to know. For instance, it's good if we know that between negative 1 and positive 1, 68%. Between negative 2 and positive 2, 95%. And between negative 3 and positive 3, 99.7%. We're looking for Z's between negative 1 and positive 1. Between negative 1 and positive 1, here we go, 400 and 600. Negative 1 and positive 1. That is 68%. Different way I could have looked at that. 34 plus 34. Still 68%. 34, 68. Okay, number 3. What's the probability that a randomly chosen exam score is above 600? So we're talking about X, exam score. Above means greater than 600. Up there just above this, I already know that 600 goes with a z-score of 1. So z greater than 1. We'll confirm that over here on our curve. 600 right here at negative 1. So what's above that? 13.5, 2.35, 0.15. We just need to add those three things up. 13.5, 2.35, 0.15 adds up to 16%. Number 4 is interesting because it talks about two different x numbers, 300 and 700, but it's not talking about the in between. It says, what's the probability that a randomly chosen exam score is less than 300? So x less than 300, or x greater than 700. So instead of talking out in between those two numbers, they're happy if it's much bigger, much smaller, just not in between. I'm going to figure out two separate z-scores for this. Z is less than, z is greater than. Gotta go look them up on the table. Z is less than 300 would be less than negative 2. And what is less than negative 2? Let me see. Here's the negative 2 line. So I'm talking about just those two things right there. 0.15 plus 2.35 equals 2.5%. It's only half my answer though. Then I'm going to look for 700. Over here on the 700, I'm looking for things that are greater than 700, which means greater than same total. Positive 2. Which is still 0.15 plus 2.35, 2.5%. But we're happy if it's less than this or greater than this, which means we're perfectly happy to have 2.5 plus 2.5, which is 5%. Another way to look at that, let's go back to our curve again, is to say between 2 and negative 2 is my 95%. If I just looked at the whole thing is 100%, subtracted off the 95% I don't want, I can still get my 5% answer. Unfortunately, when I assigned this assignment, I asked you to do these problems both ways. Once with the curve, which is what we just practiced here, and once more using the table. So let's go back to number 3 again. Number 3, using the curve. 16%. Using the table, it's going to be close, but it's not going to be exactly the same. We're still going to be dealing with x greater than 600, z greater than 1. Z greater than 1. I'm going to go over to my table and find one more page. Got to find the positive page. Say z is greater than 1. Let's find 1. It's just 1.0. 0.8413. Point 0.8413. Even if I change that into a percent, it's not even close to 16%. That's because The table tells us less than. If we want greater than, we have to do 100% minus 84.13%, so that we end up with 15.87%. Close, but not exactly the same. I can only upload a 15-minute videos, and I'm getting close. So I'm not going to do part B on number 2. I am going to do part B on number 4. I need to be, because number 4 is practically 2 problems in one. I'm going to go to my table, look for when z equals negative 2, what does the p equal? Negative 2. Here's negative 2. 0.0228. 0.0228. And again, move that decimal over 2 places to call that 2.28%. When I do it with 700, I'm dealing with a positive 2. If z equals positive 2, what does the p from the table equal? Go into the table, all the way to the positive side. Positive 2 gives me 0.9772. 0.9772. Decimal for that? 97.72%. But we know that if we look at this 2, we go above that. That is 97%. 97% would have to be to the left, but we want to know about the right. So, just like we had to do 100 minus when we were doing it up here, we're going to have to do 100 minus 97.72, which also works out to 2.28%, which totally makes sense because when we did number 4, part A, we were using the curve. Both of those were the same. Here, both of those are the same. Once again, we're going to take 2.28 and add 2.28 and end up with 4.56% for our final answer. Close to 5 that we got for the A answer, but not exactly. There we go. I think that's as much as I can fit into this video.